Okay, so welcome. So this is the first of 4 videos where I basically talk about sequence and series. And if you're just joining us, this is good. Welcome. So I'm gonna give not too much of an in-depth discussion, but focus more on the problem-solving aspect of it. My goal here is just to give you some concept background on what sequence and series is, and then I'm going to go into some really easy to difficult questions. And also, I will pose a question for you guys to answer. Please, your feedback is very important. Let me know how this video is. And also, this it would be very helpful if you watched the video starting from this one, then the second, and the third, and the fourth, instead of skipping through each video. All right, so we see here that a sequence, let me get my pen out. A sequence is a set of numbers in a particular order. Each of those numbers are the elements of the sequence. When you add all those numbers together, you get a series. Now, I gave you 3 examples here, as you can see. Here we have a set of numbers in a particular order. The order that they are in determines whether or not, no, it actually determines which type of sequence that we have. If you take a look at this has a specific order where each element is increasing by 1. If you take a look at this one, this has a specific order where each element is decreasing by half. It's going from 10 to 5 to 5 over 2, 5 over 4. And then this one has no particular order, hence it's not a sequence. I just put this one there just to show you that not every ordered list is a sequence. The third one is not. It has no type of order. The definition is a set of numbers in a particular order. Look at this keyword, particular order. This one has no order, so it is not a sequence. Now the top two are, so we need to know that. Now a sequence can be of 2 types. It can either be arithmetic or it can be geometric. Arithmetic or geometric. Now, there is a way we find out either if it's arithmetic or geometric. We need to know that. Also, a sequence can be finite or infinite. By finite, I'm not going to give you a fancy term. It just means it has an ending. There's a last number. There's a last element. In this case, 100 is the last element. So this is a finite sequence. Here, it has no ending. So this is an infinite sequence. And this is not a sequence, the third one. So now, how do we know whether a sequence is arithmetic or geometric? This is something you need to know. It's extremely important before we can even move on and answer questions about them. Let's move on. So an arithmetic sequence, as the definition here says, let me get my pen again, is they have a common difference between them, where this common difference is constant between each element, and the next term is obtained either by addition or subtraction from the previous term. So in simple English, this is the second element. This second element is obtained by adding 1 from the first term. So that 1 is the common difference. But to know that it is arithmetic, that 1 has to be the same. It has to be the same common difference throughout. So again, 1 plus 1 is 2. 2 plus 1 is 3. Then 3 plus 1 is 4. And it goes all the way on in this finite arithmetic sequence. What is the common difference in this sequence? Obviously, it's 1. Why? Because 1 is added to each element to get the next one. Let's take a look at this one. Here, the common difference in this infinite arithmetic sequence is 2. 2 is added to each element. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8, and it goes on. Again, this is an arithmetic sequence because we're adding the same number to each element. 2 is added here. 2 is added here. And then it goes on and all the way on. Now, let's take a look at this one. This one, it's not that tricky. Here, we're subtracting 3 from each number. 3 minus 3 is 0. 0 minus 3 is negative 3. Negative 3 minus 3 is negative 6. And it goes down. We're subtracting 3 from each term. So the common difference, again, the common difference is the same between each element. This is how we know that it is arithmetic, because the common difference is the same. Hope you got that. Now, geometric. Geometric is very simple, is also very similar to arithmetic. In this case, the common difference between them is a constant, and the next term is obtained by multiplication and addition. This is different from arithmetic, where you obtain the next term by addition or subtraction. In this one, you obtain the next one by multiplication or division. Take a look at this one. Well, first of all, what is the common difference? We can obviously see that the common difference is 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and it goes on. So the common difference is 2. We obtain the next term by multiplication in this one. Hence, this is a geometric sequence. Look at the bottom one. This one is also a geometric sequence where we obtain the next term by division, dividing 2 from the first term. 12 divided by 2, 6 by 2, 3 by 2, we get 1.5, and it goes all the way on by division. This is a geometric sequence. We need to know the difference and how to identify them. So let's move on. Now, there's a few types of questions that, in general, they ask you in high school when it comes to sequence and series, especially in the pre-calc class or algebra 2. You learn sequence since 8th grade math, but you really like do real problems in it when you reach algebra 2, where you deal more with like finding constant terms like a of 20 or a of 30. Those kind of things you do not do in 8th grade math unless you go to a specialized school. But again, the questions that you can get asked is not really that many. So I have tried to put together the main types of questions, not all, but the main ones that your teachers can ask you. The first is write the first few terms of the sequence given some sort of formula. So it's possible that you have some type of sequence and you're asked to write the first few terms. Like, what is a of 1? What is a of 2? What is a of 3? What is a of 4? And it goes on and goes on, things like that. So all the way it goes on. So that's one type of question. Another type is you're giving elements of a sequence, like 1, 2, 3, 4, 5, 6, all the way to 100. Find the formula that defines that. Simple. That you see questions like that a lot. Another type of question is you're given sigma notation of a sequence. Find the sum. We're going to talk about sigma notation in this video. Find the sum of that. Another one is you're giving the elements of the sum. Find the sigma notation. So that's reverse of question 3. And then the fifth one is find the nth element of in a sequence. This is the first thing that I said. Find a of 20 when they only give you like a of 1 and the common difference. Or they give you two elements that are far from each other, and you have to find like a of 100 or something like that. So these are the types of questions that they really ask. There are more, but this is the main ones that I've come across while teaching algebra and also tutoring. So if you know of any more, please post a comment and let me know. Alright, so sequence formula. Sequence formula can be of two types. It can be algebraic or it can be recursive. When I say algebraic, I mean simply just multiplying by a constant term and adding to the last one. That's the first one here. That's what we mean by algebraic. A sequence formula can be algebraic. Now, by recursive, I mean that you get the next term from literally the previous term. You're not multiplying by some constants that is the same throughout. 2 here that you see here is not the constant that separates the elements. I'll show you this in an example that we'll do next. 2 is not the common difference. You're actually getting the next term from the previous term. This is what we know as recursive formula. Algebraic, however, the D here is the difference. The D is the constant that separates each element. This is why this is an algebraic formula and this is a recursive formula. They're two different things. This is why we have a sub k plus 1 equals 2 times a sub k. Again, k plus 1. The next term is obtained from the previous term. Let's do some more practice. Let's see. Now, some of the things you need to know before we can answer these questions that I talked about, or even more of them, you need to know factorial. And I think factorial is one of the things that I've seen a lot of students just struggle with. It's a very simple concept. And the best way to teach you factorial is just to show you, rather than giving you a Google definition. If I give you 3 factorial, the way you do the factorial is exactly as you see it on the screen. You do 3, and then you have this little prime symbol. 3 factorial means 3 times 2 times 1. You stop at 1. If you want to go to 0, fine. But actually no, that's not even fine. That's wrong. 0 factorial is technically 1. This is defined. 0 factorial equals 1. So anytime you see 0 factorial, just replace that with a 1. Now, 9 factorial just means 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. That's what 9 factorial means. So if I say what is 4 factorial, again, that's very simple. It's 4 times 3. Oh, it's here. 4 times 3 times 2 times 1. That's 4 factorial. Now, if I say what is 3 factorial, 3 times 2 times 1. So if we have what is 4 factorial, divide that by 3 factorial. Again, very simple. Just break them down. 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. You see that these 3's look the same. You cross them out. What are you left with? 4. And 4 is the answer. Simple. Another way of doing this, which is the preferred way, by the way, that I prefer, 4 factorial divided by 3 factorial. You do 4, but instead of going to 3 times 2 times 1, you stop at 3 factorial. You do not go any further and you put the factorial symbol there. Why am I stopping? Because now I have the same terms. I have 3 factorial in the denominator. I don't have to expand the 3 factorial in the denominator because it matches the one in the numerator. So I just cross them out. And I'm left with 4. It saves time and it's easy that way. Let's see another example of factorial. A more challenging example of factorial. Again, n factorial. Now, n's can be any number, just like I just did. 3 factorial is 3 times 2 times 1. Here we have n factorial. It reads n factorial. Now, n factorial means n times n minus 1 times n minus 2 times n minus 3, all the way till we get to times 2 times. There should have been a dot here. I apologize for that. It should have been n minus 3 all the way till we get to times 2 times 1. That's what n factorial is. So again, n could be any number. If n is 3, for instance, right? So let's say n is 3. Then you have 3 factorial. Get this pen to work properly. 3 factorial is the same thing as 3 times 2. Sorry for my scribbling. Times 1. And that will give you 6. It's the same thing. N is an arbitrary term. It can be anything. As you can see, it's decreasing. N, 3 times 2, 2 times 1. So n times 1, n minus 1, n minus 2. It keeps going all the way down until we get to 1. Now, what if I give you n minus 1 factorial? Again, don't be confused by this. This is not really difficult. What you're doing here is you start, instead of starting with n, which takes you to n minus 1 eventually, you're starting with n minus 1 and you're going all the way down. N minus 1 times n minus 2 times n. It's the same thing. You're always decreasing by 1. I want you to know that. That's what factorial is. You're multiplying each term after you decrease by 1. So you start with n minus 1, then n minus 2, then n minus 3, and all the way. Imagine if n was 5. So basically this is saying what is 5 minus 1? What is 4 factorial? Which will give you 4 times 3 times 2 times 1. Basically, simple. Now, if I give you a positive number, n plus 2 factorial, again, follow the same logic. You decrease by 1. So if n plus 2 factorial, you have n plus 2 times n plus 1. Why? Because 2 minus 1. You subtract 1 from this 2 right here. So n plus 2 times n plus 1 times n. Then you go back down to the negative. N minus 1, n minus 2, all the way down. So let's do this example here. Very simple example that I solved already. N factorial divided by n minus 2. Take a look at this. You start with n. You go down to n minus 1. And then you go to n minus 2. You keep going. You can go to n minus 3 all the way, but there's no need to go to n minus 3. Why? Because we have n minus 2 in the denominator. So I stop here because it makes no sense going to n minus 3 when I can just have cross this out, because they are like terms. They're the same thing. n minus 1, n minus 2, and it goes down. And what do I have left? N times n minus 1. Again, this is really simple. Let me know if there are any questions with factorials. I know factorials can be a little tricky, but they can be also very easy to deal with once you get the concept of factorials. Let's move on. Now, sigma notation. Sigma notation is something that you should also know when doing sequence and series, because they ask you a lot of sigma notation questions, and sigma notation is something that I've seen students like struggle with a lot. So again, it's very simple. It's easy to understand. So let me show you a few examples here, and we can it will make our life so much easier. So we have uh, this left sum here. This big symbol means sum, by the way. Sum of all numbers from 1 to 4. That is how you read it. When I equals 1, so let me just explain here. Here I equals 1, obviously. Here I equals 2, here I equals 3, and here I equals 4. That's what the sigma notation is. Replace the I. That's what it's saying. If you don't know how to do it, replace this I with 1. That's how we got this 1 here. Then you put a plus, not a minus. The reason why this symbol is here, it means you put a plus. This symbol represents a plus, a plus between each element, plus. Then you put a plus. Then you move on from I equals 1 to I equals 2. That's why we got the 2 here. Then you move on to I equals 3, and move on to I equals 4. And then you add it all up. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. And that's the sum. Look at the next one. Again, wherever you see an I, you exchange them for the number. Here I starts from 1. So 2 to the 1, then you put a plus again, then 2 to the 2, then 2 to the 3, then 2 to the 4. Again, it's the same thing. It's nothing really that difficult. You're just replacing the I with each term, starting from the number they give you here. You don't always have to start with 1. It depends on what they give you. You can start with 0, -1, -2. Each question differs. It's not just 1, by the way. But I'm giving you examples where it's 1. Here we have 0, by the way. So again, here is 2 raised to the 1 power. Why 1? Because I is raised here. So anywhere you see an I, you exchange it for that number, and then you move on to the next one. Then you move on all the way until you reach the last number, which is always given to you on top. So then let's find the sum here. 2 raised to the 1 is 2. If I can get my pen to behave. This is 4. This is 8. And this is 16. Then you add it all up. I'm not going to add that. You guys can do that. Again, this is also similar. I here is 0. You start with 0. So you put 0 here. You start with 0. Now, -1 raised to the 0th power. What is this? -1 raised to the 0th power. Anything raised to the 0th power is 1. Anything. Take my word for that. Anything raised to the 0th power is 1. Then the next one. -1 raised to the 1st power. When you raise -1 to an odd number, you get a negative number back. Then the next one. -1 to the 2nd power. Alright? When you raise -1 to an even number, you get a positive number back. And the trend goes on all the way. And then you combine them and you get 1. Alright, so before we move on to the practice video, I would like to stop the video here and end part 1 of 4 videos. And this is just a background to help us solve the questions that are going to come in the next video. Again, if you have any questions to this, if you have feedback, comments, please leave it. If you like this video, subscribe, like it, and post a comment. Again, please make sure you watch the next parts of this series. There are 4 videos to this whole segment. Thank you.